In section 2.5, we'll be using our sine and cosine ratios to help us calculate side lengths of right triangles. And before you're here, you see the ratios again for sine theta and cos theta. And again, we studied those in section 2.4. All right, so taking a look at our first example, we're asked to find the length of a line segment BC, which is the same thing as side length little a. Okay, I have my right triangle. 5.2 is my hypotenuse. This is my angle, and side A is adjacent to angle 50. So therefore, I'm going to use the cosine function. So the cosine of 50 degrees will be the adjacent side, which in this case is side A divided by 5.2. And again, we don't need to use the units till our final answer. So now to isolate A, I'm going to multiply both sides by 5.2. So getting out my calculator, doing that calculation, my side A works out to be 3.3 centimeters. So again, when you're looking to find a particular side, look at what side they're giving you in relation to the given angle, and that will help you decide which trig ratio you're going to have to use. All right, I'd like you to pause the video and give this one a try. All right, in this example, we're asked to find side length PQ, which is really side R, and that would be the opposite side to angle 67, and 10.4 is the hypotenuse. So therefore, we are using the sine of 67 degrees, would be R divided by 10.4. Then, again, like we did in the last example, we'll multiply both sides by 10.4, and therefore, 10.4 times the sine of 67 ends up being 9.6 centimeters if we round off to the 1 decimal place. Now, if we did an extension to this question, what is the length of RQ? Okay, RQ would really be sine P. Okay, well, ignoring our value for R, we could find side P by using the cosine ratio because P is adjacent to angle 67 and 10.4 is still the hypotenuse. So therefore, we could say the cosine of 67 degrees, the side length P divided by 10.4. And again, we would multiply both sides by 10.4. And again, I would punch that into my calculator. And that would work out to be 4.1 centimeters with the side length P. Okay, taking a look at this example, we're asked to find the length of side DE, and DE is really side length F, which is the hypotenuse in this particular case. And we are given angle 55, and we're given the opposite side of angle 55, and we're asked to find the hypotenuse. So again, we're going to use the sine ratio. So the sine of 55 degrees is the opposite side, which is 6.8 divided by side F. Now this one's a little bit more challenging because the side I'm trying to solve for is in the denominator, but we faced this issue back when we did the tangent ratio. We're going to multiply both sides of this equation by side F. And on the right-hand side, side F will cancel out. So I'll be left with F times the sine of 55 degrees is equal to 6.8. And now I divide both sides by the sine of 55. And we're left with F equaling 6.8 divided by the sine of 55 degrees. And if we evaluate that on our calculator, it ends up being approximately 8.3 centimeters if we round off to 1 decimal place. Okay, now your turn. So again, pause the video, give it a try. We're looking for side length JK. Okay, looking at this question, we're really looking for side length little m, which is side length JK. So we are given angle 65. This is the opposite. M is the hypotenuse. So again, the sine of 65 degrees is going to equal 7.6 divided by m. And again, if we do some algebra manipulation on this, we're going to multiply both sides by m. So on the right-hand side of the equation, the m cancels. I'm going to divide 7.6 by the sine of 65. And now I can evaluate this on my calculator. So 7 divided by the sine of 65 degrees is going to be approximately 7.7 centimeters. All right, that concludes the first part of section 2.5. So there's some questions for you to try. Give those a whirl and check out the answers on the website if you need to.